Yeah, Thursday or Friday would be the goal date to have donuts. We are still waiting to hear the final results. There's a lot of conspiracy stuff going on with the numbers right now. Um, Mr. Fiscus has encouraged cheating, so it's always a challenge. So, if you remember, if we take the limit as x goes to a of f of x, the easiest thing to do is simply to plug in the value which you're approaching and determine the limit. But suppose we have a polynomial. Suppose we have something like the limit as x goes to infinity of x cubed. What you have to think about in that situation is suppose we take a very large number, because infinity is not a number. You can't plug it in on a number line, can you? I mean, you can't point to it on the number line. So you take a very large positive number and cube it. If you take a very large number and multiply it by itself 3 times, what are you going to get? A very, very large number that's positive, right? And so it would approach positive infinity. No. Oh, yes. This is, yep. That's our substitution rule. And many times we like to plug in a number in order to see what the limit of the function is. But the tough thing is that you can't plug in infinity because it's not a number on the number line. That's a little bit different here. Suppose we take the limit as x goes towards negative infinity of x to the third power. Well, that would be a very large negative number cubed, right? What happens if you cube a very large negative number? Yeah, and so you get negative infinity, right? But if we just switch that around a little bit, we say limit as x goes to positive infinity, or I'm sorry, negative infinity of x to the fourth. Suppose we have an even exponent in that situation. Well, that would be a very large negative number raised to the fourth power. Well, what happens if you take a very large negative number and raise it to the fourth power? Get a positive number, yeah. So you can see that you really have to think about the degree of the polynomial, whether it's odd or it's even, and think about what happens with really large positive numbers and really large negative numbers. Don't plug in infinity. Plug in a very large negative or a very large positive. Now, let's look at a similar situation here. Suppose that x is going to infinity, but we have 1 over x to the nth. So, for example, the limit as x goes to infinity of 1 over x to the 8th. Well, that would be 1 over a very large number to the 8th power. What's happening to the denominator? It's getting really, really large. You have 1 over a really, really, really large number. 0. Right? You have like 1/1 millionth, 1/1 billionth, 1/1 trillionth. The answer, it's not the number that's equal to, it's the number it's headed towards. And it's headed towards 0, right? It's becoming ridiculously small. Even if it's negative infinity, the limit as x goes towards negative infinity of 1 over x to the 8th, we would get 1 over a very large negative number to the 8th power. Does it matter whether it's positive or negative? What if the degree was different? What if it was 7? It would be negative, but it would still be getting really small, right? It's still tending towards 0. Yes. Limit as x goes to plus or minus infinity of sine of x. Let's think about that a little bit. Do you know what the graph of sine of x looks like? As I head towards infinity, does the graph like start to change and like approach a certain value, or does it continue to just oscillate back and forth? just continues to go back and forth, right? So it never, ever hones in on just one number. Anybody want to guess what the limit is? Does not exist. Now, some people get confused by that because they're like, well, Mr. Gens, we've talked about sine of x before, and it has had limits. Well, not as x went to infinity. For example, we talked about this very important limit, the limit as x goes to 0 of sine of x over x. Do you remember what that limit was? It was 1. We proved that using the sandwich theorem one day, and you all got hungry. It's a joke. Sandwich theorem, hungry. Wow, I'm really losing people today, Kaylee. This is a tough deal. But look at this one. Limit as x approaches infinity of sine of 1 over x. You saw that this limit does not exist. This limit was 1. This limit right here would be the same as the limit as x goes to infinity of sine of 1 over x. I just rewrote that. I didn't need to. It would be the sine of 1 over a very large number, right? What is 1 over a very large number? 0. So it would be the same as the sine of 0. And what is the sine of 0? 0. So you got to be very careful with your limits and understand the direction that they're heading, okay? So let's do some example problems and see what happens. It says use knowledge of limits to confirm the following limits algebraically. Limit as x goes to infinity of 4x minus 1. Always a good idea to think about the graph if you know what the graph looks like. Do you know what 4x minus 1 looks like? So as x goes to infinity, what happens to the y value? Yeah, let's show it algebraically. And here's how you show it algebraically. We take the largest degree variable, which is x to the first power, and we factor it out. Becomes the limit as x goes to infinity of x times 4 minus, if you factor out an x, what does that minus 1 become? 1 over x. Can everybody convince themselves that these two expressions are the same? Okay. So as I'm approaching infinity, that'll be a very large number times 4 minus 1 over a very large number. How would you like to rewrite it? I don't want to plug in infinity because infinity is not a number. N just represents any large number that you would like. Is there a large number you really like? Okay. She said 2. I don't know where to start with that. I guess, anyway, okay, good. All right, so if we plug in a very large number, what happens to the 1 over n? What does that go towards? Goes towards 0, and we get n times 4 then, which is 4n, or a very large number. So you end up heading off towards infinity. Give it a few examples. You'll be okay. Plenty. Yep, this is crucial. You know how to do this. Okay, and again, we want to show algebraically. I'm telling you that you can look at the graph and in order to confirm your answer. X squared minus 3x looks like that, right? So as x goes to infinity, what happens to the y value? It goes to infinity as well. The answer is infinity. Can everybody see that? Let's show it algebraically. What is our largest variable? X squared. So I factor it out. When you factor it out, what are you left with? 1 minus 3 over x. If I were to multiply these through, that's where I would come up with that x. Yep. So I plug in a very large number squared, times 1 minus 3 over a very large number. What's 3 over a very large number? 0. So you end up with very large number squared times 1, which is just another very large number, right? So it's approaching infinity. We knew it from the graph, right? The next one, almost identical. What's different about the next one? Going towards negative infinity, right? I think about the graph. Limit as x goes to negative infinity would be positive infinity. As x goes towards negative infinity, the y value still getting bigger. Let's show that. What should I factor out? Factor out an x squared, and I'm left with, good. Hey, I'll plug in not a large number, but a really large negative number. So I have negative n squared times 1 minus 10 over a very large negative number. What's going to happen with 10 over a very large negative number? 0. What happens if you take a very large negative number and square it? Large positive number. So you end up with, as we said, infinity. Yes. No. Do you know what that graph looks like? You don't have your calculator. Do you know, are you confident what that graph looks like? Okay, all right. So Gigi is 100% correct. It either looks something like that or it looks something like this, right? So Gigi, you got the general idea. As x heads towards infinity, can you tell me what the limit would be? I hear a lot of thoughts. I hear 0. Here it does not exist. Here 0. And unfortunately, nobody's right, okay? And so that's why we have to show it algebraically. And when you see it algebraically, it's not 1 either, okay? No, it's not 4. You guys are like, you're not even making good guesses at this point, okay? Watch the issue here, okay? Watch the issue, okay? And this is what's challenging, okay? Some people say, well, Mr. Gens, I just want to plug in a really large number, and so I get 2 times a really large number over a really large number minus 1, right? So they're like, oh, well, you get a really large number then over, well, 1 minus a really large number is still just a really large number, so we get 1 out of that. And it's not correct. It's not. I'll show you. Okay, how about this? You plug in infinity. 2 times infinity is infinity. And infinity minus 1 is infinity. Infinity divided by infinity is 1, right? No! I will factor out the largest term in the numerator. What's the largest term in the numerator? X. So we're going to take out the largest variable, okay? So I take out x, and I'm left with 2. What are we going to take out of the bottom? Another x. And you're left with? Sweet. Time out. Look at it. What happens to the x's? Okay. So therefore, I get 2 over 1 minus 1 over a very large number. What is 1 over a very large number? 0. So you get 2 over 1, which is 2. Isn't that cool? Is everybody okay with that? Folks, so as you're trying to process this, I want you to consider, do you see how you have the same degree in the numerator and the denominator? Okay, look at this. You have a larger degree in the numerator than you do in the denominator here. What will I factor out of the numerator? I factor out an x cubed, and I'm left with 4 minus. What do we factor out of the denominator? X squared. And you're left with 1. Okay. Something that you should be catching on to now at this point is what happens with these denominator pieces. 1 over x cubed, 2 over... Yeah, they all go to 0, right? Because 1 over a very large number cubed is going to get very small. So it looks like... And what happens to the x cubed over the x squared? So we have x on top. That's gone on the bottom. So we have a very large number times 4 over 1. Oh, I'm sorry. Is it a very large positive number or is it a very large negative number? So I have a very large negative number times 4 over 1. What's that going to produce? A very large negative number. So the answer is negative infinity. Because we're approaching negative infinity. I substituted for the x a very large number. Yes. But I'm plugging in a very large negative number. So if I take x and I substitute in for it a very large negative number, I get a negative n. Okay, that's where the numerator was bigger than the denominator. What do you notice about the next one? The denominator is larger. I can't factor anything out of the top. But what can I factor out of the bottom? X squared. And you're left with? What's going to happen to 3 over x and the 7 over x squared? So I get 6 over a very large negative number squared. These two? Because 3 over x, when you plug in a very large number, it's going to be like 3 over a billion, which is going to be really, really small. So anytime you had that polynomial in the denominator, it's going to go to 0. Got it? Flip it. Okay, folks, here's where we need to be smart. You try the next 3 on your own. Go. Okay, as you're working through these, are you getting them? Is there an issue that came up with any of them? The last one, I had the last one placed because I was hoping that people would come up with negative infinity. But you do see that it's 0 minus 6, so you have to account for the negative 6. We all okay there? Okay. Whatever the largest variable is, the largest degree variable. So x squared you're going to take out, and x you're going to take out. Yes, yes, it's different top to bottom. Yep. Yep. Okay, we're going to skip this one, and we're going to go to this one. And I'm going to tell you right away, okay, that you could just look at this and see that the answer is negative 2/3. Now, you're not going to do that on the test. You'll show your work algebraically, but it's a nice way to check your answers. And here's the deal. Here's what you should be noticing, and hopefully you do. See how the denominator is bigger than the numerator? When the denominator is bigger, the denominator will win out and your answer will be 0. See here how the numerator is bigger than the denominator? Because it's an x squared. Yep. And so then, since the numerator is bigger, it's going to win out. Your answer will either be positive infinity or negative infinity. What do you notice about this one, the numerator and denominator? Same degree. So all you have to do is just consider the 4x and the negative 6x. What's 4x over negative 6x? Negative 2/3. Now, I'll show you the work in just a second here, but that's the same type of situation that we had happen right here. Look at 2x over x minus 1. You just do 2x over x, and you get 2. So you can tell right away when some of these things are going to occur, and you'll see exactly why that happens here. What do we factor out of the top? You factor out x, and you're left with 4 minus 1 over x. What do you factor out of the bottom? And you're left with 5 over x minus 6. So you can see that what happens with our work is that these smaller terms simply disappear. They end up going to 0 anyway. The x's end up canceling out. And you get that 4 over negative 6, which is negative 2/3. You got it, kiddo. So look at the next one. I'm headed towards infinity. And that's, Grace, that's when you're headed towards infinity. Not when you're headed towards 5, not when you're headed towards 1, not when you're headed towards 0, but when you're headed towards infinity. So, or negative infinity. Rebecca, what did you say for the next one? Y. Denominator is bigger. Now, I'm not going to take the time to show the work, but notice adding 1 billion and subtracting 1 billion, that might matter in the short run, but how does infinity compare to a billion? I mean, it's infinitely times larger, right? So although these numbers appear large, they really have no impact on it over the long run. The answer is 0, okay? Yes, you would, but I'm not going to right now for the sake of time, but I will expect you to do so. And I'm confident that you can do it after you've seen the amount of work that we've done. Okay, this looks super complicated now, right? Because we have a square root. It's no big deal. Limit as x goes to infinity of, what do you think I factor out of the top? An x squared. And I'm going to write it as x squared times what's left? 5 plus 2 over x over squared over, what do I factor out of the bottom? X times can you reduce this square root of x squared? So limit as x goes to infinity of x times the root of 5 plus 2 over x squared over x times 7 plus 1 over x. What's going to happen? X's cancel. What else happens? And you end up with the square root of 5 over 7. Try the next one on your own. What? Well, that's hard to say. In this situation, it's easy to see that the x to the fourth and x to the fifth were different. They're both written as polynomials. But here, when I look at it, I see that the square root of x squared is x. So I really feel like they do have the same degree. Try the next one on your own. Go. Okay, limit as x goes to infinity of x squared times 8 over, you factor on x to the fourth, which becomes x squared, times 2 minus 6 over x to the fourth. You take the x to the fourth out, and then when you take it out of the square root of the x to the fourth is x squared. So you should have, those are gone. This goes to 0. You have 8 over the root of 2, which is 8 roots of 2 over 2, which is 4 roots of 2. Okay, you're doing well. What do you think you factor out of the next one? So we have the limit as x goes to infinity of 2 times the square root of. Can we skip a step here? When you take an x to the sixth out, it will become x to the third, right? So we have 2x to the third times the square root of. We took out an x to the sixth, so we'll have 1 over x to the fourth plus minus we have the limit as x goes to infinity of 2 times the square root of, I'm going to take out an x to the sixth. It becomes 1 over x to the fourth plus 1 minus 3x cubed. That x to the sixth comes here. So we have the limit as x goes to infinity of 2x cubed times the square root of 1 over x to the fourth plus 1 minus 3x cubed. Okay. Uh-oh. You plug in this one here, it goes to 0, right? Well, and we're going to. What do you think we should factor out of the 2x cubed and the 3x cubed? Yep. And so you get the limit as x goes to infinity of x cubed times what's left here? 2 minus 3 will give you negative infinity. Very good. A very large number cubed times negative 1 will be negative infinity. Okay. Negative 3 sine of x. What do you think? Does not exist. You can't really do this algebraically. You need to consider the graph, and you guys know that the graph looks like this, right? How about the cosine graph? Cosine graph would be the same thing. What's that? Nope. Anytime you make absolute statements, it makes it very difficult. So, no. So, classic example. So, Gigi said anything with sine or cosine will just be does not exist. This would be a classic example. Here I can factor something out. What should I factor out? When I factor out the x, I get sine of x plus 3. And here's where people's thinking generally starts to fall apart. So see if you can focus. I know that that's going to become a very large number, right? Now, when I take the sine of a very large number, that's not necessarily a very large number. Well, at largest, it would be 1, right? I mean, the sine of a number at most can be 1, right? How about the least value of sine of a number? negative 1, right? So either you're going to have sine of 1 plus 3. I'm sorry, sine of a number at most is going to be 1 plus that 3. Or it would be negative 1 plus 3, right? So suppose sine ended up being positive 1, okay? You would end up with 4 times a very large number, which would end up being infinity. Or you could have, what would this end up producing? 2 times a very large number. That would end up producing. So even if sine is its smallest value, its least value of negative 1, it's still heading off towards infinity. Wouldn't you agree? So therefore, the overall answer is infinity. Good work. There is one more example we didn't get to, but we'll have to do it tomorrow. I'm going to give to you your worksheet. You're going to have one more assignment after this. I will give it to you tomorrow. And there are definitely 2 assignments you do not want to slack off on. No.